Okay, so in this video I'm going to have a look at modulus inequalities. So we have these inequalities here, but we have this these absolute symbols here. We're getting the absolute value, or the modulus of x minus 7 being greater than or equal to 3, less than 10. So what I'm going to do is I'm just going to split this up first of all into this here and this here, and I'm going to do them separately and then put them together, put the solutions together at the end. So first of all I'm going to take this 3 being less than or equal to the modulus of x minus 7, and over here I'll do x minus 7, modulus of that being less than 10, and I'll do these separately. So let's start with this one here. Now what you can do here, there are a couple of different ways of doing this, and I'll do it a different way later on in this video, but for method number 1, if you like, what I'm going to do is I'm just going to write down this, and I'll just explain it in a minute. So we're going to take x minus 7 being greater than or equal to 3. That's just reading it directly here, taking away the modulus signs here, the absolute value sign. So write down x minus 7 greater than or equal to 3, and I'm also then just going to write down x minus 7 being less than or equal to minus 3. So why didn't I leave this symbol the same way around for the minus 3? Well, let me just explain that here. Let's say, for example, we have the modulus of some number being greater than or equal to, let's say, we'll use 3 again, okay, we'll say 3. So what number here, such that when you get the positive value of it, that's what absolute value mean, the absolute symbols here mean, you have to get the positive value of x, what numbers can be greater than or equal to 3? Well, if you take your number line here, for example, you've got, let's say, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and they go on forever in both directions. So what values here, such that when you get the absolute value of them, will be greater than or equal to 3? Well, you can say here that x will be greater than or equal to 3 anyway. So in other words, all these numbers up here, all these numbers here, will be greater than or equal to 3. So x can be greater than or equal to 3, and if you get the positive values of any of these numbers here, the absolute value of these x values up here, they will all be greater than or equal to 3. Now if I had not have changed this around, I just had have said x is still greater than or equal to minus 3, so I didn't change this around. Well, let's see what we would have ended up with. We would have ended up with these values here. Greater than or equal to minus 3 would be all these values up along here. Now if you take any of those values, let's say minus 2, the modulus of minus 2 is equal to 2. 2 is not greater than or equal to 3. 2 is not greater than or equal to 3, so that's incorrect. If you take 1, for example, the modulus of 1 is 1. 1 is not greater than or equal to 3. So this is incorrect. This part here is incorrect. So what we actually have to do is flip that around. X is less than or equal to minus 3. So let's have a look at those solutions. So x is less than or equal to minus 3 will give me solutions down here. Less than or equal to minus 3 will be down here. So if we take, for example, minus 3 itself, or if we put minus 3 in here, we will get the modulus of it. Get the modulus of minus 3 is equal to 3. 3 is greater than or equal to 3. It's actually equal to it, so that's fine. Let's take minus 4. Well, if you take minus 4 and get the modulus of it, well, that's the positive value of minus 4 is 4. 4 is greater than or equal to 3, so that works. So these do work, so this is correct here. So when you're doing the modulus here, modular inequalities, you've got to say use this symbol directly first. So x minus 7 is greater than or equal to 3, and then x minus 7 is less than. You've got to flip it around for the negative value here. So let me just get rid of all this stuff first. Now, so that's why I flipped this around here. Okay, so that's that one there. Now I'll just put a line down here because I'm going to separate these. So here then we've just got, we can add 7 to both sides, so x is going to be greater than or equal to 10, and over here then we've got x is going to be less than or equal to 4. X is going to be less than or equal to 4. So the solution on this side then is just going to be x is greater than or equal to 10 and x is less than or equal to 4. So that's my solution from this side of the inequality. On this side here I do the same thing again. I have an x minus 7. I'm just going to write down less than 10 here, and then I'm going to write down x minus 7 greater than minus 10. So again here just solve this, add 7 to both sides, you get x is less than 17, and over here then we've got x is, add 7 here, greater than minus 3. So our solution on this side then is going to be x is greater than minus 3 and x is less than 17. Okay, so these are our two solutions here, and what I'm going to do here now is just combine these two solutions. Got to combine these two solutions. So, as remember, we've got it. This is what we've got to solve. We didn't have to solve this or this on its own. We've got to solve this here. So we've got to combine the two solutions. So let me just write out. We'll do a number line first, and I'll just show you what way I'm going to. The logic behind this. This solution. So just bear with me for a second. This is going to be minus 4, minus 3, minus 2, minus 1, 0, 1, 2. I've got to go all the way up to 17 here, so just bear with me. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and let's go to 18 as well. So we're going out in both directions here. Now, if we take this here, for example, what we're looking for here to 10, or equal to 10, is going to be here, so it can be equal to, I'll put them on top here rather than on the line. So we put in a dot there, and it's going to be greater than or equal to 10. So it's going to be up along here, all the way up along here, goes out forever. And then it has to be less than or equal to 4, so this is my 4 here, so it's going to be all the way down along here as well. So that's this solution here. Now what about this one here? Well, we need x to be greater than, I'll do this in a different color, let's say we'll go for green here, I think. Okay, so x is going to be greater than minus 3. So here's minus 3. Again, I won't do it on the number line, I'll just do it off the number line. So greater than minus, sorry, it's actually down here, my fault, down here, so it's going to be greater than minus 3. So there's minus 3, so normally you'd put a circle around it because you don't want to include it. And it's going to be everything up along here, but it has to be less than 17 as well, so it's going to be from here to here. Again, we put a circle here at 17, and we're going to go all the way down along here to minus 3. So this is the solution on the right then. Now, what we've got to do is solve for both of these, this one and this one here. So what we've got to do is write down the solution of effectively what's the overlap of these two. So we've got to look at this area here and this area here is the intersection of if you like, of these two solutions. So what are we looking at here? Well, here we want x to be, so the overlap solution and the final solution here is just going to be x is going to be greater than minus 3, and it's going to be less than or equal to 4. That's this bit here, if you like, all this bit in here. Now we don't want this because this is only one of the solutions, it's not part of the other solution, so we want this bit up here as well. So we've got this bit up here, that's going to be x is going to be greater than or equal to 10, so it's going to be greater than or equal to 10, and it's going to be less than 17. Less than 17. It doesn't include 17. So this is our solution here. This is the solution to what we were asked for originally. Okay, so that's one way of doing this. That's method number one, if you like. Let's have a look at another way of doing it. So our original question was this one here. 3 is less than or equal to the modulus of, or the absolute value of x minus 7, and that's less than or equal to, no, it's just actually less than 10. It's not equal to it, and x again is an element of or. Now, what we can do here is just separate out the variables here again, separate out the inequalities, I should say, and what we're going to do here is just square both sides. So if we take the left hand side as 3 is less than or equal to the modulus of x minus 7, and on the other side then we've got x minus 7, the absolute value of x minus 7, being less than 10. Now if we square both sides here, if we square both sides, so here we'll get 9, and on this side then we'll get x squared minus 14x and then plus 49, and over here then we'll just get 0. If we subtract 9 from both sides, x squared minus 14x plus 40. So we end up with a quadratic inequality, and I've done something like this earlier on in a previous video then, how to solve these kind of things. So let's have a look at this side here. If I square both sides, we get x squared, we get minus 14x again, we get plus 49 again, and then on this side we just get 0. No, we don't, we get 100. That's not a 0, it's a 10, so we square 10, we get 100. Okay, so then just bring that over, bring the 100 over, we get x squared minus 14x, and we get minus 51 there. Now we get 0 on this side. Okay, so now we just solve this the way we solve normal inequalities. So first thing you do is let the x squared minus 14x plus 40 equal to 0, because we want to find the roots. We want to find where it cuts the x-axis, so that's going to be equal to 0. So we've got an x here, an x here. We've got 40 here, but we're looking for 14 in the middle, so that's probably going to be 4 tens, I think. So we'll do 10 times 4. We want a plus, so it's going to be minus minus, because we've got a minus here. So that will give me x is equal to 10 or 4. Now, so I'll just stop there for the moment with that one, and I'll just finish this one off. So we do the same thing here. So we're going to let x squared minus 14x minus 51 equal to 0 to find the roots. So that will give me x here, 51 is going to be, we want 14 in the middle, so it's going to be 3 17s. So 17 here, 3 here. I need a plus and a minus because this is minus here, so I need two different signs. I want the biggest one to be minus, so we'll take this one as minus, this one here is plus. So that will give me x is equal to 17 or minus 3. You probably recognize these numbers from the previous solution. But let's have a look. We're solving inequalities here now. So let's have a look at what our graphs would look like if we were to graph these inequalities in this case. So we have 10 and 4 here, so our graph will look something like this. So we've got a 10 here and we've got a 4 here. Now, what inequality are we actually wanting to solve? Well, we want to solve this inequality here. This is what we want to solve on this side. So this is y greater than or equal to 0. This is what we want to solve. Y greater than or equal to 0. Our x squared minus 14x plus 40 is just y, if you like. So we're looking for positive or positive values of y, or y equal to 0. So in other words, we can include this number here and this number here because it's equal to 0 as well, and we want greater than, so we're looking at these values up here, this part of the graph up here, this part of the graph down here. So what x values, and we've got to include the 10, include the 4 as well. So what x values are we looking for? Well, these x values here and these x values out here. Okay, so what's that solution? Well, that solution is just simply, I'll do it in white here, so x is going to be greater than or equal to 10. So these x values out here. And x is going to be less than or equal to 4. That's these x values down here. So what about this one over here then? Well, again, we need a 17 and minus 3 as our roots. So we have our graph will look something like this time. So this is going to be, remember our inequality here now is less than 0, so we don't include these two values here. If it was less than or equal to, we would include them. So we just put a circle around here. Well, actually I'll do it in blue again. So we don't include our roots here, our two roots. So we have this here, by the way, is 17 and this here is 3. Now we want, in this case, we want y to be, what do we want to solve here? So it's this one here that we want to solve. So this is y here less than 0. So we want y to be less than 0. That's what we want to solve here. So y less than 0 then is just going to be everything down here. All these values here have negative y values. So this is y less than 0. What x values give us these particular y values? Well, all of these ones in here. All of these x values here give us all of these y values down here. All of these points down here which have negative y values. So let's have a look at the solution for this then. We're looking at x being greater than, this is actually minus 3 here, I should have a little minus there. So x is greater than minus 3 and x is less than 17. Okay, so they're actually the same solutions that we got in method number 1 up above. So you need to combine these two the same way as I did before with the number line that I did, and you should end up with the same solution. You should end up with the final solution there was x is greater than minus 3, less than or equal to 4, or x was greater than or equal to 10, less than 17. So when you combine these two solutions again, this one and this one here, you should end up with these two solutions down here. Okay, and that's the second method. You can there is a third method here that you can use algebraically. If we take our inequality again, so let's take, we've got 3 less than or equal to the modulus of x minus 7, and that's less than 10, and x is an element of OR again. What you can do is just directly here square everything. So you can say here this is 9, this is going to be x squared minus 14x plus 49 again, and this is going to be 100 over here. What you can do now is, let's say, subtract 9 from all sides. So you get 0 here, you get x squared minus 14x plus 40 here, and here you get 91. What you would need to do now is just separate out the inequalities. You can't really go any further with this. So what you would do is maybe take this inequality here and do it, and then you would take this inequality here and do it. Similar to the previous example, you would end up with the same kind of solution. So I won't actually do it. It's exactly the same as the previous method, but you end up with the same answers anyway. Okay, and that's really it for solving these inequalities here with absolute values in them, with modulus, these modulus symbols here.